Okay, so for this sort of first unit, the first unit is on measurement. And lesson number 1 is going to be an introduction, and we're going to kind of talk about one sort of main topic. There's not a lot of notes that you have to write down. There are a few things that you probably kind of could and should write down, and I'll at least make reference to them. And of course, you can always go back and watch the video or go and see the notes that are online and sort of write those down then. Because there's going to be a lot of text that kind of just tell a little bit of history or some interesting facts about measurement. And yeah, so this first lesson is kind of just a bit of an introduction. I have 2 little cartoons here, and they kind of little funny, but they illustrate sort of why is measurement important, right? The cartoon on the left, the guy's selling foot-long hot dogs, and so you kind of have at least an idea of, well, what should that mean, right? And of course, the customer, he's not very happy, right? Because he's kind of like, look at the size of this wiener, right? And he's saying, well, look at the size of my foot, right? That's what the vendor is saying. So foot-long hot dogs, this guy says, well, it is a foot long. It's my foot long, right? So that's kind of the humor in there, right? You know, same thing with the second one, right? You got this tailor, and he's got suits made to measure. And he's measuring how tall he is, and he goes, oh, you're exactly the same size as me. Well, of course, if you make a suit the same size as what the one guy wears, the other guy's not going to fit. All right, it's going to be either too big for the guy in the blue, or it's obviously going to be too tight for the guy in the salesman there. So when we talk about measurement, we use language, right? We use words. And I know this isn't an English class, but words are important, right? They always convey meaning. When you see that sign, foot-long hot dogs, you anticipate, well, especially kind of growing up, hopefully, with a little bit of understanding of, well, what does that mean? It doesn't mean the length of the guy's, you know, heel, ankle, and toes, and arch support, right? So what is a foot? We have a preconceived idea, right? So isn't a foot like the guy in the picture kind of showing his foot? Well, no, because we have a preconceived idea of what a foot should be, right? So measurement, you know, why did people need to measure things? How did people measure things? What kinds of problems arise without standards of measurement? Right? So when we talk about why did people need to measure things, why do you think people needed to measure things? And we're just going to make a list here. Whether you choose to write it down or not doesn't matter. It's not something that's kind of going to be tested for you. Yep. So they could. Okay. Okay, so to make houses. Okay, well, at least we do nowadays. Maybe, you know, at some point in time, somebody kind of said, you know, I mean, like to make a house, maybe you just need to put some sticks together, put a kind of a doorway together, you know, and have a hole in the opening. Say it again. It could stay together if it's made well. But the question is, why do we need to measure? When did the concept of measuring become important? So in terms of our building process, right, something kind of happened. Okay, or to make maps, right? So to make things, to make maps, right? Because maps, if you kind of look at a history of maps, you kind of got, you know, fuzzy shapes that sort of said, well, I think it looks kind of like this, and then as you got to measure, you know, got a more accurate picture of, you know, things that are true. And that's kind of, you know, going back to the building, same thing with maps. It's really to get an accurate picture. Right? To get an accurate picture of something, right? Because when you draw a map of North America, it's kind of some kind of shape. But by measuring and knowing, you know, kind of how long is, you know, or how wide is Saskatchewan, for example, compared to Alberta, right? How big is Ontario? Of course, people think Ontario is so big, right? It's fairly big. Quebec is even bigger. How big is PEI? Well, it's kind of just really small. You have an idea, right? So you measure. Other things or reasons why people need to measure things that you can think of? Yeah. Simplify communication, right? Because that one comes down to kind of this one here. What kinds of problems arise without standards of measurement? Miscommunication. Right? And that's illustrated in that picture. Right? Miscommunication. The vendor is communicating foot-long hot dog, the size of my foot. Yet the customer is understanding, or hopefully understanding, thinking that, right? Again, this would be the misinterpretation, that a foot means that particular size, right? 12 inches, so to speak. Right? So miscommunication is a problem that arises. People need to measure things to simplify communication. Now, I want to go back to Bronwyn's thing about making things, and you kind of said, if I just said, you put sticks together, and you made a comment. Well, you remember what that comment was? Okay. Wouldn't necessarily stay together. If you don't measure things, when you build something, there can potentially be a safety issue. Right? So people measure things to make sure that things work, to make sure that things are safe. Right? When it comes to a doorway, we want to make sure that it works properly, right? So that it fits properly. Second question in there: how did people measure things? April? Okay. Generally speaking, at least initially, right? Body parts. Okay. In fact, that's where we get a lot of some of those initial measurements, right? Body parts, one thing, because that again is something that's very, handy in a sense. Other ways that people measure things?
Was that supposed to be a pun?
I know it kind of was. At least you're smiling. Thank you. Okay, so rulers. Well, in order to make a ruler, people kind of had to establish something, right? And again, where did the inches come from? Actually, okay, so they made devices right, that were hopefully standardized in some way, shape, or form. When we talk about a ruler, again, we have a preconceived idea. How long is a ruler? I say, go to the store and buy a ruler. What are you thinking of looking for?
Meter stick.
Okay, so meter stick is a certain length of a ruler, right? And we call that a meter stick. Ruler would be right, a foot long, right? Most rulers, okay, so here's a ruler, right? Here's a ruler, right? It's about a foot long. I have another ruler somewhere. Right? Ruler over here, right? A foot long. Typically, when we think of ruler, we think either of this size or the 6-inch one, the ones that come in the little math sets, right? That's typically what we think of when we think of ruler. Well, when did this become the standard? When people realized that this was the most effective method for certain things, okay? So body parts, they made devices like rulers. Now the question you might, again, kind of in your head, did they use other devices before rulers? The answer is yes. And so we're going to kind of look at some of those. And one of the main things that we kind of move towards when we move from body parts to devices is we use certain standards for measurement. So that when we say we want something to be a foot long, like a hot dog, that there's a standard as to what that means, right? That it doesn't just mean the length of the guy's, foot, right? But rather some other standard is really what we're using to measure. Morning. Almost full today, not quite. Okay, so here are some examples of some unusual measures that were used. Okay, and some of them became standards that eventually dropped out of use. The first one is a furlong. This was and still is kind of a very common example. A furlong, which means furrow length, was the distance a team of oxen could plow without resting. Now you don't have to write this one down. You can go back and watch this one. And this was standardized to be exactly 40 rods. So what's a rod? Was this a rod, the ruler? Well, no, but something like it, right? So the rod, which is the next one, is kind of a standardized unit of measure. Furlong, anybody know where the word furlong is still used? Not so much, but there's a specific context. It does have to do with kind of something about farms. Horse racing. You ever listen or TV, or if you go to Northlands Park here and they talk about horse racing, they still use that specific distance, right, in terms of how many furlongs is something. Okay. Next one is a rod. Bars of metal, 1 rod long, were used as standards of length when surveying land, right? So April, I think you came up with the idea of maps, right? Right? And so some standard, it's kind of like, well, I've got this land. Well, I've got this land. Well, how much land do you have? Oh, I got about this much. Well, they used some standard of measure to sort of be able to say, here's how much land a person has. So bars of metal, 1 rod long, were used as standards of length. The rod was still in use as a common measurement until the mid-19th century. So that's like 1800s, right? 1850, 1860. The early Anglo-Saxon rod was based on the North German foot. What does that mean? Is that the 12 inches or is that the... the rod used for land measurement was equal to 15 of these feet. By about 1300, England had switched over to the foot and the yard of today, but kept the rod at its original length because much of English land had already been surveyed and measured using the older unit. Okay, so there's kind of a bit of a history as to how, you go to England and you look at some of their pieces of land and you wonder, how big is that? Whereas if you ever fly, right, if you fly out of Edmonton and you look at the land in Alberta, Saskatchewan, right, it's very square, right, organized in terms of squares around our country, right, and that's because obviously our country developed much later, than England, and so the way we measured land was much different. Right? Another example is a chain, right. In 1620, the clergyman Edmund Gunter developed a method of surveying land more accurately. This is pretty accurate, with low technology equipment, using what became known as Gunter's chain. This was 66 feet long. Okay? And why a chain? Well, because it can be straightened pretty well, and it's always very consistent in terms of how long it is. Right? The word transferred to the actual measured unit. His chain had 100 links, and the link is used as a subdivision of the chain. Right? The chain also survives as the length of a cricket pitch. Huh, that's kind of interesting. Right? We have a cricket pitch here in Edmonton, right, down at Victoria Park, so I can tell you how long a chain is. Being the distance between where the 2 wickets are. A chain is exactly 4 rods. So there's actually kind of a connection between a couple of these different units of measurement, right? Rods and chain. And then another example here is a league. Anybody heard of 20,000 leagues under the sea? So it's another distance. It's kind of an interesting one. The league was originally referred to as the distance a person or a horse could walk in an hour. Of course, you might think, well, horses maybe walk faster than people, or certain people have longer strides than others. On land, the league was most commonly defined as about 3 miles, right? 3 miles, about 4.8 kilometers. Although, again, the length of a mile could vary from place to place and at different times. At sea, a league was 3 nautical miles. So a nautical mile different from a land mile. And so when we talk about these terms, measurement, we kind of get vague pictures of, in this particular case, distances. So measurement, right, when we talk about, Guérin sort of said, to simplify communication. Throughout time, we've kind of refined, well, what does this mean? We've tried to make our language, we've tried to make things more clear in terms of what do these different units mean. And then a last one here, this one is actually still used, and that is a hand. Oops, that's not what I wanted. And my finger is just a little off. There we go. Take this and delete it. There we go. Right? A hand is the width of a human hand, and it was used, and still is, to measure the height of horses. Right? And a hand is basically set as 4 inches. It's kind of, again, been standardized. right? Now, the following are, sorry? Well, what else are you going to use? Feet? Can't quite do that with your feet. It's pretty easy to measure with your hands. 1, 2, 3, 4, 5, 6, 7, 8. Right. Now we're just going to make a list here of some devices that can be used to measure lengths of various objects. Now we've heard a couple of these kind of already this morning. We've heard ruler, right? You know what a ruler is. Meter stick. Can you think of other devices that you've heard of, seen, maybe even used to measure the lengths of various objects? Okay, so measuring tape. What kind of measuring tape? Okay, so to measure what? Give me an example of what it is that you would measure. Sorry, loud. Cloth? Okay, so like tailoring measuring tape, right? The one that's kind of fixed at, I don't know how many inches it is, right? So measuring tape. All right, for fabric. Now, there's something particular about that kind of measuring tape that makes it really useful, right? And that is that it's very flexible, right? Because you use that measuring tape, for example, to measure around your waist, right, or around your shoulders, right, or around your head. So it's very flexible. It bends. Okay. Other examples of measuring tape or something else? Yeah, Ashley?
Measuring tape, like you would use to measure like a 2x4.
Okay, so for construction, right? And those ones are usually longer, right, than the measuring tape for fabric, and they're also typically not very flexible, right? They're typically a little more rigid. That one, I have an example of that one, right? So this kind of measuring tape, right? And you want them to be not very flexible so that you can, at least if you're a construction worker, kind of doing some measuring by yourself, you can measure some distances, you know, so this is what, this is over 5 feet, without kind of losing your tape, right? Or having to have another person to help you. Okay, so that's measuring tape for construction. Other kinds of measuring tape that you have seen or heard? Okay, or any other device, yeah, you bet.
Those lasers that surveyors use.
Mr. Pollich, do you know the name of that? Are you a surveyor? You're surveying right now. I don't know what they're called. Yeah, an infrared laser. Yeah, so we'll see. We can just call it an infrared laser used by surveyors to measure distances. Well, let's pick up where we left off. That's the one you had mentioned, right? Gary on. Okay, what kind of device is that? Okay. So it's a mathematical. It is mathematics, right? We will get into that a bit, I think, in this course, more in 20-1. And even there, if you're going to use trigonometry, you need to have something already measured. So right in this particular list, we're going to focus on just kind of specific, kind of concrete devices. But yeah. Okay. Now, a protractor is a measuring device. Yeah. So measuring angles, that's what a protractor does. That's absolutely correct. Just for lengths, like just distances or lengths is kind of what we want to focus on here. Yeah, Jad. Okay, how do you use it? Okay, and what does it measure? By? Okay, so I'm not, I've heard the word before. I think, and you can go home and Google this, or you can Google it at lunch or at break. I think it uses, first of all, location of stars, right? And I think that also then refers to kind of angles. So, and then what I think they use it for is they use also what's called a transit. I'm not exactly sure. Somebody could probably correct me. The transit is kind of like, it's another one of these things that could be found in a geometry set that kind of walks across a map to refer to distance. So I'll put it up there, but I think it refers more to angles, but I'm not sure. Okay, and it's again, and it is used, but probably not so much today, maybe. I don't know. Okay, others, maybe more common ones. Which? Graphing? Not to measure lengths. I know we're running kind of, ruler meter stick. That's kind of some tape measures, kind of the sort of extent of what we have. I want to introduce you to, if you haven't seen these before, I want to introduce you to at least two more that are probably more common than you think. The first one is one that's used for measuring longer distances, and it kind of has taken the place of a measuring tape. When you do sort of track and field, if you do like a discus throw or a javelin, right, or shot put, you use a measuring tape. Police, when they want to sort of take some measurements for an accident, for example, instead of pulling out a big measuring tape, they use a specific device. And that device is called trundle wheel. Right? And here's an example of a trundle wheel. And the thing is, somebody obviously invented it because they didn't want to have to reel back in the tape, right? Or the tape would kind of get squished, or it would get bent, or it would get folded. And so this trundle wheel, right, has just a wheel that spins, and then there's kind of like a little odometer, right, kind of like on a car, right, that shows how much distance has passed. And so that way you can relatively quickly, okay, put it down here, and I can just walk across the room. Whoops, got to make a little detour, right? And then I can look and say, oh, my room is about 24 feet wide. Do most of them click? Depends. Depends on kind of the mechanism that's inside here, right? And so a trundle wheel it's just kind of an easier device to use than a measuring tape, right? And so police will use that because then it's easier to kind of walk a long distance. Like you could probably walk the whole block, right, and measure that rather than kind of using a measuring tape and then kind of having to pick it up and walk a little bit further and then pick it up and walk a little bit further and then add all those numbers together. So a trundle wheel is probably a very common and very useful one. The last one that I'll quickly show you is called a caliper. And some specific models are called a vernier caliper. And the caliper is not used to measure things that are really big, but are used to measure things that are much smaller. For example, I can use this to measure, and this would be an example that, if I asked you to measure the width of the leg on your desk, how wide is the leg on your desk? Well, there's a couple inherent problems, right? Number one is the leg is round, and you can't really measure kind of across it, right? Now you could, perhaps, using, let's say, that fabric tape that Jay talked about, right? You could measure the diameter of it, or circumference of it, the circumference of it, and then use some math, right? Use a formula to calculate the diameter. Well, this is a device that, hold up your finger, right? You can just gently, it's not going to cut off, gently squeeze it, and now that has measured the outside diameter of your finger, or you can do that for particular sizes. People that are, call them arborists. You know what an arborist is? Arborist is a guy that takes care of trees. Okay, they use a caliper to measure the size of a tree. Right? If you move into a new neighborhood, okay, in the city of Edmonton, some developers say if you're planting a tree in your yard, it has to be at least 2 inches. Caliper measure. That's what that means. That means that the diameter of the trunk of the tree has to be at least 2 inches. They use terms like that. So that's a caliper. Yeah. Question. And they're different, right? They're different up top as they are kind of at the bottom, except for a couple of them. Like your desk, it's the same thickness all the way through. Another thing that's hard to measure that this device can be used for is the depth of something that's kind of inaccessible, right? And here's an example. Well, the most common example is the depth of tire treads, you know, like on your car. You have kind of a thickness of the tire tread. So the way they measure it is they use something like a caliper. And I'm going to illustrate that by sort of asking, how deep is this pencil sharpener? Right? And the answer is, well, if I can't stick a measuring tape inside there, right, and I can't assume that it's as deep as the entire object is tall, because maybe the bottom here is a little bit thicker, right? Because this oftentimes gets dropped, and so maybe they've made it a little bit thicker on the bottom. So what the caliper can do is, you see that little sliding sort of stick at the bottom? By sliding that stick in, oops, there's the 0, right? By sliding that stick down, that can measure the depth of something. So I can slide it in there and push it down, and okay, now that's not the entire depth, but because it's kind of stopped at the bottom of the pencil sharpener. But that's something that this caliper can be used for, measuring things that are just, you know, can't measure it with a ruler, can't measure it with a meter stick, you know. So there are specific devices that have some really sort of good uses to measure things. Another thing, for example, that I've used it for, is if I want to, you know, hang something, or I'm building something and I want to know, or here's kind of an example, this pin. All right, so this little push pin. I'm interested in knowing how thick is, you know, what's the diameter, in a sense, of the metal piece of the push pin. Well, it's really small. Now I could put this beside a ruler, and I'd kind of say, well, it's, you know, it's small, right? And so what's the smallest unit of measure that you know? Okay, so yeah, it's less than a millimeter. So can I be more precise than that? Right, so that's, again, that's kind of what this object can be used for, because this object, this caliper, measures more precisely than a ruler does, right? And in fact, this is a different measuring device. It's actually called a micrometer, but it's the same basic concept as the caliper, and it measures, this can measure the thickness of like 5 pieces of paper, right? Which your ruler can't do. And so when you're constructing things, and sort of the more valuable the thing is that you're constructing, the more precise measurements you want to take, right? The more precise your devices need to be. And so when we go back to this kind of question about what kind of problems arise without standards of measuring, there's miscommunication. There's also lack of precision and lack of accuracy when it comes to measuring things, right? How thick is that push pin? It's about a millimeter. Well, that's not very precise, right? But if I can, you know, say and use a device that measures more precisely, then I can be sort of more specific, more exact. Now, here's kind of the sort of the focus, in a sense, of today's lesson. When a device is not available, okay, so no rulers, no calipers, no trundle wheels, no tapes, but you need to measure something, right? When a device is not available, but we still desire to measure something, we need to use what's called a referent. Okay, and so today's lesson is on kind of just an introduction, and it's about reference. So what is a referent? Okay, well, a referent, so you want to make sure that this kind of definition you get down, a referent is an object, or it can be a body part, right, that you can refer to in helping to estimate certain lengths. And I really want to emphasize this word. It's an estimate, right? It's not very precise, right? It's an estimate. A personal referent has something to do with your body. Okay, so a referent itself just simply means it's an object that you can refer to so that you can approximate or estimate the length of something. Okay. So, some examples of reference that are non-personal. If I asked you to measure the width of your desk, right, one of the most common reference that you have, hopefully, with you is a sheet of paper. Right? Because your sheet of paper, most sheets of paper have fixed dimensions. Do you know what the dimensions are?
No, 8 by 11.
Close. eight and a half, right? So, and 8.5 by 11, what? Inches, right? So units are important when it comes to working with measurements. So absolutely. Sheet of paper, very common, is actually 8.5 by 11 inches. Now, if you kind of said, I think it's 8 inches, you know, you'd be okay because it's an estimate, right? So you pull a piece of paper and you go, okay, 1, 2, 3, 4, 5. 5 times 8 is 40. It's about 40 inches. Okay, so 40 inches is pretty close, you know. So that's why if you kind of say it's about 8 inches, you'll be okay with that. Right? If you know more specifically, and the 11's dead on, so you know, use something that you know is a particular size. A CD or a CD case, and again, you might have to, well, CDs are kind of like, what's a CD? You guys know what a CD is anymore? Okay, well, because I was listening to, I know you're not that old. I was listening to the radio, seriously? Okay. I was listening to the radio and they were kind of talking about, they're bringing back vinyl. Right? Because, you know, vinyl records. Well, vinyl records have passed and gave way to cassettes. Do you guys know what cassettes are?
Yeah.
How about 8 tracks?
What? Yes, actually.
Okay, so, you know, certain things that used to be kind of common and CDs, you know, had been kind of common. They were about, I think, 12 centimeters. All right? Sort of, you know, so things like that. If you happen to have a scrap piece of lumber, because I know actually you referred to kind of piece of lumber before, right? Piece of lumber has some pretty, you know, depending upon which piece it is, some pretty specific dimensions. Okay, so a sheet of paper, very common to have around. Anything else that maybe you have in your pocket, your purse that you know the specific dimensions of, Bronwyn? Yep. Okay, so your binder, right? And again, if you know, because certain binders may be a little bit, you know, they got a little bit more stuff at the end or the width of it, right? But any object that you know the dimensions of.
Your finger, like the lines.
Okay, well, we'll get there. We'll get there because those are what we call personal reference, right? They're physically part of your body. These ones here are so the concept of a referent is something that's not a true device. And object-wise, you know, a sheet of paper can be something. Maybe you've got anybody got their license, learner's license, or student ID card? Okay, do you know how big those are? Because if you did, then you could use those as a referent, right? Just as an example. Okay, so something that you have that you know the dimension of. The personal examples we'll get to in a second here. Okay, so when we look at our sort of referent, we've identified here 8.5 by 11, and we used specific units, inches, right? Of course, in Canada, there are 2 primary systems used for measuring dimensional objects, right, that are very commonly used. Now, of course, there are a number of different ways that you can measure, but the 2 most common units or systems are, first one is the imperial system. Right? And then the second one is, we commonly call it the metric system, but it actually has a longer name, and that name is System International, right? But it's in French, right? So SI is kind of the official name for it. We typically call it the metric system. That's right. And both of these are still currently used. Okay. Now, the metric system itself was actually kind of brought in, or at least into Canada in, anybody know when? Yeah, the early 70s. Okay, so before you were born. I remember in school when suddenly this came in, right? And because when I was in school, we had the imperial system. We used to be able to drive 30 miles an hour or 60 miles an hour, and then suddenly the speed limit went up. Woohoo! Instead of going 60 miles an hour, we could go 100. But it was kilometers an hour, right? So then it's kind of like, oh, it's really the same, right? It's just a different way of measuring something. So imperial system, those are things like, well, I just said miles. And the metric system, not equivalent, but sort of closest type of measure, right? Miles would be the same as kilometers. What other units can we think of for imperial that has a sort of somewhat similar in terms of metric? Inches, okay, so inches. Okay, and we'll talk about the reference for those. Others? Yard. Yeah. Okay. And the yard has a fairly close equivalent in terms of the metric system. Right, and that's the meter. And I'll just put it as M for meter. Okay, inches has a fairly close one, not quite. There is a conversion that goes between them, right? The centimeter. Okay, we're missing one here in the imperial system. Feet, right? Okay, and there's no, I mean, there is a conversion, and there's no specific one that's about the same length. But of course, the nice thing about the metric system is that there are just different prefixes, right? We have kilometers, something, meters, something, centimeters, something. Okay, so millimeters, very common, right? Those are kind of the most common ones: millimeters, centimeters, and meters and kilometers. Anybody know what those other ones are in between there? Yeah, Sandra? Okay. Okay, so the one below the kilometers is hectometers, HM, which is the same as like the 100, it's basically 100 meters, right? Because the nice thing about the metric system is that it's really just a power of 10. Sandra, another one? Okay. Well, no, you named them both, right? Because those are two different ones. Decimeter, right, is a tenth of a meter, so that's the same as 10 centimeters. And then the decameter is when you have 10 meters, right? So the width of this, no, the length of this classroom is about a decameter, right? It's 10 meters. Maybe not quite, but you know, that's the idea. Whereas the decimeter is sort of like the CD case. Or is it a can of pop? I think a can of pop might be like 10 centimeters. Right? So again, just depends on your referent. Right? And the imperial system, we've got miles, yards, feet, inches, and then the inches break down into fractions of inches. Right? So that's why a lot of people kind of don't like the imperial system, because you got all the fractions. Whereas with the metric system, it's basically just decimals. Right? Okay. Now, with the imperial system, we're just going to look at some, you know, where did that imperial system come from? How did it get developed? What are some of the relationships there? All right. So, first of all, the inch. Originally, the width of an adult thumb. It comes from the Latin word uncia, which means 12th part, which is kind of interesting because that's how we get that 12 inches makes a foot. Right? And so here's one thing to note. For the inch, the thumb width is a good referent. Now, that's an adult thumb width. So if you're not quite, depending upon your size, and in grade 10 we've got people of different sizes, it may be actually, instead of the width of your thumb, a good referent could be from the knuckle to the tip of your thumb. Is also pretty close to an inch. Okay, that's not a... And for some, it's because it's almost square. It's not quite square, and it depends. Some people have longer fingers. You know, kind of. Everybody's body part's a little bit different, right? I think the eyeball is the eyeball an inch. Of course, that's not really an easy referent to use. Right? Doesn't quite work. So again, referent is something that's readily available. So these are now personal referents, right? Your thumb is a personal referent that can be used for an inch. The foot. Right, 12 inches, obviously named. Although a standard was not set until that mid-19th century, right? 1850s, 1860s, somewhere in there. And again, depending upon the size of your feet, with or without shoes, can be used as a referent. Okay, so personally, most of my shoes, like not my feet, but my shoes are about 12 inches. So when I want to measure something, I just walk with my shoes on, because that's pretty close to a foot. Okay. So again, kind of think of the referent. The yard. Okay, so the yard, right? Again, this is an imperial measure. The yard is 3 feet or 36 inches. Okay, very specific. And a good referent for it is a stride, right? A single stride. Back in Henry I, who lived between 1100 and 1135, decreed, because he was a king, decreed the yard to be the distance from the tip of his nose to the end of his thumb. Right? And that's why it's called imperial measure. He was the king, what he said went, and that was the yard. Okay? And it was within a tenth of an inch to the modern yard. So in other words, that was pretty consistent and pretty close. Right? So the yard, a good referent is a stride, but again, it kind of depends, right? Some people that are shorter, that yard might not quite be there. Some people that are taller, that might be too long. So, but more or less, right? Again, referent is something that's used to approximate. And so it doesn't have to be very precise. That's the thing about a referent. Okay, the mile, derived from meal, which is Latin for 1,000, and so you think, well, isn't that like the kilometer? Right? It was 1,000 Roman paces. The modern mile is 5,280 feet, or 1,760 yards. And again, those are now more precise because those are accepted standard units of measure, the feet and the yards. And so here's the thing about, here's Canada, right? Range roads and township roads are spaced by the mile. So as you drive along the Yellowhead, if you're going off to Saskatchewan, you see 221, 220, well, I guess not 19 anymore. That would be 215, 214, 213, 212, 211, 210, and then whatever the next one is, 206, no, 205, 204, right? Range roads and township roads are all spaced by a mile, and they're counted in specific things. That's why you won't see a township road, 228, you won't see one, because they only go up by sixes. Right? And then a 6 miles by 6 miles is called a township, I think is what it's called, right? In terms of land area. So approximate mile, it depends on which city blocks we're talking about, but about 10 city blocks is a mile. Okay, so Grote Road here is about 134th Street. Okay, so 134th to about 144th should be about a mile. Okay, more or less. Okay, so that's again a referent. Okay, 10 city blocks. Now it's not a personal referent, right? But then again, maybe as far as I can run, as fast as I can run in however many minutes, but probably not. Typically a mile is either 10 city blocks or, and again, it kind of depends, right? Because these are approximations. As you're traveling down the highway, if you're going 100 kilometers an hour, it's the distance traveled in a minute, right? Because if you're going 100 kilometers an hour, that's technically 60 miles per hour. And so in 1 minute, you go 1/60th of 60 miles. So you go 1 mile. Right? So a minute goes by, that's another mile. And if you're driving along the road, you can kind of tell that distance between the range roads. But of course, nowadays we travel faster than 100 kilometers an hour. Okay, but that's the idea of a reference. Something that you have, could be a part of your body or something that you can step that can be an approximate measurement for something. Okay, so that's the imperial system. The metric system. Okay, so the foundation of the metric system is the meter. Originally, it was intended to be 1/10,000,000th of the distance from the Earth's equator to the North Pole at sea level. Okay, who thought of that? Certainly wasn't. Anyway, since 1983, okay, in other words, not that long ago, although it's still long ago, it's defined as the length of the path traveled by light in a vacuum, and we don't mean the Electrolux model, in 1,299,792,458 of a second. Who do you think comes up with these numbers?
You.
No, not me. Scientists, that's right. See, scientists and mathematicians. Because then it's no longer precise. Oh. Well, it's easy, that's true. And it's good for an approximation. But you know what scientists are, right? They're like, well, no, it's not that they like to make things difficult. No. Some of my best friends are scientists. They make things precise, right? We want to find out what's true, right? That's what scientists are interested in. Okay, mathematicians are interested in that too. So we want to be as precise as possible. Now, here's kind of a bit of interest, and you'll kind of see how it goes from, isn't that good enough, to being more specific. In 1790, the French National Assembly decides that the length of the new meter, so this is obviously a lot long ago, would be equal to the length of the length of a pendulum with a half period of 1 second. So what that means is that the pendulum swings kind of, from here to there. That's a half period of 1 second. And so that kind of pendulum, if it swings that far, well, it's about a meter long, right? Because it took 1 second to go from here to there, right? And it kind of doesn't matter the distance, right? Whether you drop it from here to there or from here. The half period is, if it's 1 second, this length is a meter, right? That's pretty interesting. 1 year later, actually not even a year later, that same French National Assembly accepts the proposal by the French Academy of Sciences that the new definition for the meter to be equal to 1/10 millionth the length from the equator to the North Pole. Now, who's going to travel that? Yeah. Okay. 1795, only 4 years later, so a lot of stuff happening here in the late 18th century. The provisional meter bar is constructed of brass. So somebody finally said, hey, let's make something. Let's make something concrete so that we can say, hey, this is a meter right here, right? So they constructed it out of brass, except there's a bit of a problem with that. 1799, 4 years later, December 10th, the French National Assembly specifies the platinum meter bar, constructed on the 23rd of June, 1799. Now, why do you suppose they wanted to use some other material?
Doesn't brass like change volume or something?
How about, what measure are we talking about? Length, right? So it changes length. With what? What causes it to change length? Corrosion could, right? But brass, see, the thing about brass is brass doesn't corrode very well. So, but it does do something else, because you talked about moving. Temperature, right? Right? Hopefully, as scientists, budding young scientists from junior high, you remember that if you heat something up, it expands, gets bigger. Okay, so in France, I'm assuming the sun shines in France, and so it probably got a little bit longer in the summer, and in the wintertime when it's cold, like here, it gets a little bit shorter, right? So in other words, it changes, and as things go through changes like that, something else tends to happen to that object. It kind of tends to lose its true shape, right? It warps. So that's why platinum, right? Different kind of material. And then a little bit later here is historical international prototype meter bar made of an alloy of platinum and iridium that was the standard for hundreds of years. Well, not quite hundreds of years. 1889 to 1960. Okay, so obviously they've kind of come up with some kind of material that, despite the weather changes, does not change very much. Right? In fact, so small that you probably have to, a micrometer to measure the distance that it changes, or something else. 1927. The seventh something or other adjusts the definition of the meter to be the distance. Aha, now they've qualified an actual temperature at 0 degrees Celsius between the axes of the two central lines marked on the prototype bar of that platinum iridium. Okay, so in other words, they said at this temperature, that's when we'll make that measurement. Right? If it's warmer than that, there is a potential for a little bit of an expansion. When it's colder than that, there's potential for something to be a little bit shorter. And then back in 1960, October 14th, we'll celebrate that next month. The 11th Congress maybe defines the meter to be equal to 1,650,763.73 wavelengths in a vacuum of the radiation of a particular krypton 86 atom. Wow. Some scientists have too much time on their hands to study that. That's my opinion. And then in 1983, October 21st, so this is now kind of where we stand, right? This is where we stand. We've gone away again from that object, that physical object that can change in temperature. And the 17th, whatever that happens to be, defines the meter as equal to the length of the path, and then this kind of goes back to the light moving in a vacuum during the time interval of that particular time. So very precise, okay? Very precise. So just a little bit of little bit of history. Now, let's go to common reference or reference for common metric units. This is, again, something that you should sort of make some notes of. And so here we've got sort of 8 descriptions, and these 8 descriptions basically kind of align with common metric units. Okay? And again, this sort of depends on your personal reference. Right? So if we start with the largest of them, the kilometer, which referent would sort of be closest to the kilometer? Actually, so 8 city blocks, right, is pretty close to a kilometer. And in fact, here's where, when you kind of look at the city of Edmonton, you know, this is 130, what did we say, 134th. Next major street over is 142nd, right? 134th to 142nd, that's about a kilometer. And then 142nd to 149th is the next major one. It's about a kilometer. There, that's only 7, but, you know, around 8 city blocks. So that's our kilometer. In terms of the next one down would be the meter. And the meter would be represented by basically the length and stride, right? Because we said it's similar to a yard. And so it's, you know, if your stride is a yard, then a meter is just a little bit longer, right? In fact, a meter is only about a hand width longer than a yard, right? A yard is 36 inches, a meter is 40 and a half. So a length and stride would be a meter. Next one down would be the decimeter. My pen is kind of losing its position there. Okay, so the decimeter, right, which is 10 centimeters, would be close to your hand width. Right, so that's the height of a horse. Remember when we talked about hands? 10 centimeters is your hand width. And then keep on moving down, centimeters and millimeters. So the width of your pinky finger, or again, depending upon the size of your fingers, it may need to be another finger. The width of your pinky finger is about a centimeter. That's a decent referent for it. And then a millimeter is about the thickness of a dime. All right. So that's a kind of a good referent. Not many people have a kind of a personal referent that would be about a millimeter, maybe the thickness of a couple of your fingernails or something. But so those are very common reference for the metric system here. Now, a couple of kind of interesting things or cool things about measurements, and especially about your personal body. How tall are you? Well, did you know that there's a very close relationship between how tall you are and your wingspan? In other words, the distance from fingertip to fingertip. So this is a useful referent because if you know how tall you are, you can quickly measure relatively longer lengths. Rather than strides, you can measure them using your body, your wingspan. Yeah, because it's a very close relationship. It's pretty close to 1-to-1, right? However tall you are, that's your wingspan. Now, it's not perfect, right? Because there are some people whose wingspans are a little bit longer, right? Some swimmers, like Michael Phelps, apparently, his wingspan is significantly longer than he is tall. And you get other people whose wingspans are a little bit shorter. Their arms are just a little bit shorter, right? So it's not perfect. It's not perfect, but it's close, right? So that's, again, another kind of referent that you can use is your wingspan, you know, as a quick way of measuring something. Now, these 3 questions, and actually other questions like it, right? How far do you live from school? Okay, so time-wise, right? About 15 minutes away. Okay, well, that doesn't, you know, I mean, in terms of a radius, so we kind of say, well, is that 15 minutes by car, by bike, by walking? Okay, how fast do you walk? Well, what do you mean normal? Because when I'm walking with my wife, at least if we're exercising, her normal walk is... Okay. Okay. So time-wise, okay, how else can we say how far do you live from school? Caleb, 8 blocks away. Okay, so you kind of have a defined sort of unit. Now the question is, okay, some blocks are longer than the other, right? So you get kind of an approximation. Bronwyn? You live a city away. So I live on the other side of the city. Okay, so that gives you a picture, right? Or if you say I live about 3 miles, right? So about 3 miles. Okay. What's the temperature like outside? Cold? Below 0? Okay, it actually is. I think it's above 0, but right, it's about 6 degrees or whatever it happens to be. We use language that communicates, but sometimes it's less precise than others, right? Yes, it's cold outside. At least that's a bit subjective, right? Subjective, yeah. It's a bit subjective because for some people, great weather outside, right? Or you could say it's freezing because like I have 4 children, right? In case I didn't tell you this before, my number 2 child, he wears shorts all year round, even in winter, even in Edmonton, and he goes, "I'm not cold," right? And he's kind of a if he ever listens to this, Nate, I love you, but it's kind of crazy. And then my 3rd child, daughter, when it's like 20 degrees outside, she's got like long sleeves on because she's freezing all the time, right? So you perceive temperature kind of differently. No. It's just she feels cold, and so that kind of feeling. What's the temperature outside? Right. That was the question. What's the temperature like outside? Cold. It's a bit subjective, right? But we can kind of say, well, if it's 6 degrees, then we have a bit more of an idea, right? So we use certain types of measurement to be more precise. How much money do you have? Lots, right? Or not enough. Or you can specify to the nearest cent how much is in your bank account. That's pretty specific. What time is it now? Like, what's the time?
Time for you to watch.
Okay, time to get a watch, right? You could say, well, it's morning. It's half past what? Half past skin? Oh, if you don't have a watch, okay. Half past the left artery. You could say that that's 10 o'clock. Like you could say it's first block. Right? You could say it's almost midweek.
It's about that time.
Right? About that time. It's fall. Well, it was fall for like a day. So the concept of time, right? Again, our language for it, we would like to have some level of precision. And so here's the thing, right, about reference. And here's the thing about measurement kind of all the time. Anytime that we talk the language of measurement, we talk about something called either approximations, right? If we can use, if we don't need to be terribly precise, or we need to use more precise measurements when we want to ensure, right, clear communication, when we want to ensure accuracy. And so I've got just kind of one last little cartoon here that I thought was kind of funny. Okay. This was kind of like me when I met my wife. Well, no, but it was a baking incident. It was a baking incident. Okay. Now I'm a math teacher, so certain things are important to me as a math teacher, right? Precise language is important to me. Okay. So I'll tell you a little story, and it's not about the baking pan. Anybody not getting the joke though about the 9 by 12 baking pan? Right? It needs to be inches, right? That's the 9 by 12 baking pan, and that's the common measurement. Okay. So those of you that bake, anybody bake lots? Okay, so you're going to probably laugh more and just view me as a lower individual, but that's okay. So I'm baking muffins. I want to bake muffins because I like muffins. And so the instructions on the muffin recipe, so I bought a package, kind of said, put in, this muffin mix with so much water, and then it says hand mix. So what does hand mix mean? It did not say take a spoon. It did not say using a fork. It said hand mix. So Well, why not? That's what it said. Right? So I thought, well, this is the best thing, because then at least as I'm mixing it, I can feel where the lumps are, and I know that it's pretty good consistency. And then and so my wife, who is kind of like you know, you've baked more, and she kind of like, what are you doing? I said, well, the recipe says hand mix. And then she kind of fell over the floor laughing. I said, well, if they wanted me to use a spoon, they would have said use a spoon, or if they, well, as opposed to what?
So using an actual
Electric mixer, right? So I didn't know that. You know, I thought if you want me to do something specific, be more precise, right? Give good directions. So they were not precise. If you bake lots, it was an honest mistake. Thank you. Well, then now you know what you can avoid. Now you know what you can avoid. Okay, so that's basically the end of sort of the introduction to measurement and the concept of reference. You have your homework guide there, and I will write it up here on sort of this next page. From your textbook on page 15, I'd like you to have a look at questions 1, 2, and 4 to 6. And they're just some basic get you thinking about sort of working with reference. And it's, you should be doing it. I mean, we've got almost, about 20 minutes left. You should probably be able to get this done before you go. So is it due? Will I be looking for it? I will be looking for it, but not necessarily tomorrow. So I do want to make sure, though, that you are kind of keeping up with your homework. You know the date of the unit exam. You know that our quiz is going to be that next Friday on the 19th, so at least you can anticipate when sort of things should be done. I'm just going to turn this off, and then I'll answer your question.